Hi guys, welcome back to another tutorial. Today we're going to talk about solving a linear system using substitution. And we're going to learn it through an example. So here's a linear system of two equations, and we want to find the solution to this system. X equals 3y minus 10 and 5x minus 2y equals 2. So before we get started, let's come up with a plan of exactly what we're going to do. And pretty much the plan stays true no matter which example we would use, with just one or two exceptions. So substitute the equation that has one variable by itself into the other equation. So we can see one of these two equations has one variable by itself. It's the one in red. Obviously the one in blue has the variables on the same side of the equal sign, and in fact this looks exactly, in fact it is, standard form of a linear equation. Now this looks similar to slope-intercept, except that the y and the x have been switched, okay? But the idea is that this variable is by itself. So one of the two equations has one variable by itself. Okay, so the next thing we're going to do is use the distributive property if necessary. Sometimes in these problems it will be, sometimes it won't. Then we're going to combine like terms if there are like terms to combine. We're going to find the value for this variable by solving the equation. So we're going to solve whichever equation we're working on. Then we're going to take the answer to that, the solution to that, and determine the value of the other variable. Because remember, in order to find a solution for a system, we have to find the value of x and the value of y. So we have to come up with two values, and together they make that point of intersection. Finally, we're going to check our solution in each equation if possible. So let's get started. Okay, so the first thing we're told to do is to substitute. Now remember, substitute means that since we have x equal to this, that means that x and 3y minus 10 are the same things. So we can replace or substitute in 3y minus 10 wherever there's an x. Now you can see there's an x next to the 5. Remember that 5 is the coefficient of x. And what does 5 or a coefficient always do? It always multiplies the variable it's next to. So since x equals 3y minus 10, we can replace x with 3y minus 10. That's called substitution. So x becomes 3y minus 10. Why? Because they're equal to each other. Okay, so once again, x can be replaced with 3y minus 10 because x is equal to 3y minus 10. So we substitute in, and the next thing we're told to do is to distribute. Okay, so we have the 5 times 3y minus 10, and whenever you have a parenthesis with a number in front of it, that tells you that you're going to have to do some multiplying. You're going to have to distribute whatever's in front of that expression. So the 5 multiplies the 3y, and the 5 multiplies the negative 10. Now notice I use the word and you know always means plus. Okay, so we're multiplying 5 times the first term, 3y, and we're multiplying 5 times the second term, which in this case is a 10, but there's a minus in front of it, so we can call that a negative 10. Everything else stays the same, guys. If you look, 5 times x minus 2y equals 2, just like it does up here. But x has been substituted with 3y minus 10 because x equals 3y minus 10. Okay, so now we distribute. So distribute means to multiply our terms. 5 times 3 is 15y, and 5 times negative 10 is negative 50. And the rest of it we just bring down. Okay, we didn't multiply anything there, we just bring it down and add it to the overall equation. Now, if you look at this, we have a plus and a minus next to each other, so we want to clean that up. Plus and a minus next to each other is always a minus, right? So we can simplify that and make 5y plus negative 50 into just 5y minus 50. So we're done with our distribution. That's all we needed to do. Now we have to combine like terms. Well, what are like terms? Like terms are terms that have the same numbers, okay? Not meaning that 15, if we look at these, none of the numbers are the same, well, except 2 and 2, right? But the idea that 15y and 2y both have the same variable, okay? And 50 and 2 are both just numbers, okay? So those are actually like terms too. But in this case, we're looking at combining these two like terms, 5y and minus 2y, because they both have y's in them, okay? So if we combine those two, they become 13y. Why? Because 15y minus 2y's is 13. 15 minus 2 is 13y. And you can see we didn't touch that minus 50 and we didn't touch the 2 yet. We're going to do that next. So that's combining like terms. We're done with combining the like terms. Now we have to find the variable for this variable, the value for this variable by solving the equation. So since we're subtracting 50, remember we want to get all the numbers together. The numbers right now, or the constants, are on opposite sides of the equal sign. We want to get them on the same side. So since we're minusing 50, we want to do the opposite. Inverse operation is plus 50. And because we're dealing with equations, whatever you do on one side, you want to do the same thing on the other side. So the opposite of minus 50 is adding 50. But since we add 50 here, we got to do it on the other side. Now watch what happens. Okay, 52 minus 50 plus 50 is 0, right? So what do we do? If we look down here, we did get all the constants on one side of the equation and all the variables on the other. And what does this say right now, really? That 13y's equal 52. 13y's equal 52. But we don't want 13y's. We want to know what the value of 1y is. So since we have 13 of them, we want 1. We're going to divide both sides by 13. Why? Because 13 divided by 13 gives us 1y. And since we have to divide this side by 13, we have to do the same thing to the other side. 52 divided by 13 is 4. So our answer, the first part of our solution, is y equals 4. Remember, to find the solution to a system, we need to find the y and the x. So we found the y. Now we have to find the x. So the next part, determine the value of the other variable. Well, we have the y. Now we have to find the x. So we're going to use substitution again. This time we're substituting y is equal to 4. So any place we see a y, we can substitute in 4. And if we look at this equation, it's already set up beautifully for us. If we put the y in there, we're going to be able to solve for x. So 3 times y, okay, which is now 4, is 12. 12 minus 10 is 2. So we have our two values. We have our x equals 2 and our y equals 4. So we found the solution. Now the last thing to do is just check your solution. Okay, so our solution is x equals 2, y equals 4. Since we used this equation to find out what x was, let's use this equation to check. Okay, you could check in both, but we're only going to check in this one for right now. So 5x minus 2y equals 2, and we know that x is 2 and y is 4. So 5 times 2 minus 2 times 4 equals 2. Once again, what are we doing here? We're substituting. We're substituting x with 2 and y with 4. So we're substituting again. Now we're going to evaluate and see what we come up with. 5 times 2 is 10. Minus 2 times 4 is 8, and 10 minus 8 is 2. So 2 does equal 2. Notice we didn't do anything on the right-hand side. All our work stayed on the left-hand side. Why? Because when we check, we want the left-hand side to be the same as the right-hand side when we're done. It is, so we know our solution is correct. Our solution for this system is 2, 4. And remember what that is once again, guys. That's the point where these two lines intersect.